Hello everyone! Let's begin with a simple thought. Imagine you touch a cup of hot coffee with one hand and a bottle of cold water with the other. Instantly you feel the difference. One is hot, the other cold. But how do we scientifically measure this sensation? That is where temperature comes in. Temperature is simply the degree of hotness of a body. In physics, it is linked to how fast the molecules inside a substance are moving. Faster motion means higher temperature, slower motion means lower temperature. Mathematically, we say average kinetic energy of molecules is directly proportional to temperature. In symbols, we write E average is proportional to T. So remember, temperature is not the same as heat. It is the indicator of hotness, measured in scales we can read. Now, here's a classic confusion. What is the difference between temperature and heat? Heat is energy in transit. It flows from a hotter body to a colder body until both are balanced. Temperature, on the other hand, is just the reading of how hot or cold something is. For example, a cup of tea at 90 degrees Celsius feels hotter than a bucket of water at 40 degrees. But the bucket actually contains more total heat energy because it has much more mass. So the lesson is clear. Temperature tells us how intense the heat is, but heat itself depends on both temperature and the quantity of matter. That's why scientists always keep the two terms separate. Let's now look at how temperature is measured. You've all seen thermometers, those slender glass tubes with mercury or colored alcohol inside. When the bulb at the bottom is heated, the liquid expands and rises through the capillary tube. The scale alongside the tube has been calibrated using two reference points: the ice point at 0 degrees Celsius and the steam point at 100 degrees Celsius. Other thermometers may use Fahrenheit or Kelvin scales, but the principle is the same: uniform expansion of a liquid that we can measure. As you can see in the diagram, the bulb, liquid column, and marked scale make it easy to read the temperature of a body. Different regions and sciences use different temperature scales. On the Celsius scale, we mark 0 at the melting point of ice and 100 at the boiling point of water. The Fahrenheit scale, commonly used in the United States, sets ice at 32 degrees and steam at 212 degrees. But for physics, the most fundamental is the Kelvin scale. It starts at absolute zero, that is minus 273 degrees Celsius, where molecular motion theoretically stops. And there are no negative temperatures on this scale. The three are connected by a simple relation. C by 100 equals open bracket, F minus 32 close bracket by 180 equals K minus 273 by 100. This relation allows us to switch between scales with ease. Let's now dive deeper into the microscopic world. What does temperature really mean at the molecular level? Temperature is a direct measure of the average kinetic energy of molecules. The faster they move, the higher the temperature. The equation that captures this is E average equals 3 by 2 kBT. Here, kB is Boltzmann's constant, and T is the absolute temperature in Kelvin. So if you double the absolute temperature, you double the average molecular kinetic energy. At absolute zero, 0 Kelvin, molecules are at rest. No motion, no energy. This is why 0 Kelvin is the ultimate cold. Let's solve an example to see these conversions in action. Suppose we want to convert 40 degrees Celsius to both Fahrenheit and Kelvin. We start with the relation C by 100 equals open bracket F minus 32 close bracket by 180 equals K minus 273 by 100. Substitute C equals 40, so 40 by 100 equals F minus 32 by 180. Multiply across and we get F equals 104 degrees Fahrenheit. For Kelvin, the conversion is even easier. Add 273, so 40 plus 273 equals 313 Kelvin. Thus, 40 degrees Celsius corresponds to 104 degrees Fahrenheit and 313 Kelvin. Always remember, Celsius to Kelvin is a straight addition of 273. So let's sum up what we've learned. Temperature is the degree of hotness, connected directly to the average kinetic energy of molecules. It is not the same as heat. Heat is energy on the move, while temperature is the indicator of molecular activity. We measure it with thermometers. using different scales like Celsius, Fahrenheit, and Kelvin. And at the microscopic level, temperature is all about the kinetic energy of particles, with absolute zero marking the lowest possible limit. So the next time you check the weather forecast, sip hot tea, or step into an air-conditioned room, remember, those temperature readings are snapshots of the invisible molecular dance happening inside matter. I hope this session gave you a clear understanding of temperature. In our next lesson, we'll see how temperature differences drive heat transfer and change our world. See you soon.